we can move on to our next speaker, which is Rhys Burns from up north. Rhys, over to you.
Yeah, hi Josh. Just trying to get the right screen.
Get the right screen.
Here it is. I think it's that one. Is that working?
It's looking good. If you can hit start on your slideshow, we'll get the.
Yep, thought I did. Yep.
Beauty. Okay, off you go.
Okay. Kia ora tātou, hi kaimahi ahau mō te papatawhai, no Rotorua ahau, ko Rhys Burns taku ingoa. So I was asked to talk to you today about what forest managers might want in order to get more birds in the bush. So today's presentation is really just my own personal thoughts on how we could try that. It's not a doc official view, at least not yet anyway. And also I'm not a forest manager as such. My role in the department is a technical advisor to the department in the terrestrial science unit. Right, so when asked about how we can get more birds in the bush, so I'm just trying to clear something on here. That's no good. Oh yeah, okay. So when asked what do you want, of course we want more birds in the bush, and as a department manages over about a third of New Zealand's land area, having more birds in the bush over truly landscape scales is really what we do want, but we also want it as cheap as possible. So rather than having a list of really quite hard demands or impossible demands really of researchers, I'd like to actually offer another perspective and put forward a bit of an idea, and like to, it'd be good to get any feedback that you have. And so first of all, I don't have any data to present. So what you do when you don't have data, you have a conceptual approach. So my concept that I'd like to show to you, it does lend itself to large landscape scales, and it's based on intensive background, an extensive background area blended in with an intensive management approach as well. And so I think it'd be great to try to explore different options about how that approach could be optimized. And one thing about it is that it does require more management than what's currently happening in some places, so it does require more dollars. And so I guess some of the questions could be, is the extra investment actually worth it? Okay, so we've got, if there's no treatment happening in a site, then there's actually not that many birds in the bush. We all know that. But in the old days, before predators really turned up, there were heaps of birds in the bush. And with current landscape scale pest control, aerial 1080 and such, we actually do start to get more birds in the bush in some cases. But my kind of challenge, I guess, to everybody is, can we actually do a bit better than that and get even more birds in the bush than we're currently getting with over landscape scales? So by putting this suggestion forward, I'm making two assumptions: that we can't eradicate rats, at least not in the foreseeable future, and we can't use aerial 1080 annually. So my concept really that I'm talking about really has its origin in Te Urewera mainland island, which was a big project that started in the mid-90s, and it really had a large landscape scale area it had a background area. This light green stuff is about 40,000 hectares, and that had 3 years, 3 yearly possum control, down to less than 5% RTC. And then we had these little core areas as well, which are the dark green areas in here, and they range from about 200 to 700 hectares, and there were 5 of them spread over different areas. And then we had some stoat control around some of them as well, and they had stoat control within them as well. And then there was also a bit of deer control in some parts as well. But the core area, they were kind of based on where the highest priority species were, which in this case was kōkako, and John knows a lot about that. And so my kind of question about this is, what is the was that the optimal spatial arrangement and size of core areas? And if it was going to be, say, taken to another site, would we do something similar? How transferable would a concept like this be? And then, so, ultimately, what is the optimal spatial layout to achieve more birds in the bush? So we can update this concept a bit, update and even upscale it. And instead of the 3-year possum trapping, we could say 3-year aerial 1080 as the background effect, background management. And by doing that, you'd actually get a lot more benefits than just possum trapping. Of course, you'd get the possums, but you also get the rats and the muscular control over very large areas. So just by doing that, you're probably achieving a lot for, to obtain the more birds in the bush, and it would be less expensive as well as the 3-yearly possum control, or the ground control that was done that way. And so just a clarification, because we are talking about Te Urewera, and it isn't managed by the department. So what I'm talking about isn't to say that anything should happen at that site. It's to say that take this concept and could it be used at other sites. So first of all, trying to work out what kind of core area you might require, and the optimal size. Well, there's a whole lot of stuff that could go into this, and it's really about part of it anyway is a blend of the vital rates of the pests themselves and the effectiveness of the management. So we'd start with that, thinking about that. And so we have a management area here, and then you have pests trying to get in despite your best attempts, but then you have kind of a benefit area that other native species do extra well in. And obviously it's a bit more complex than that. It's going to be patchy, and there's probably some kind of gradient there, and it will vary in space and time, but as a concept, we'll stick with that. And if you have highly effective pest control, or perhaps even a very, very large core area, you may get a high benefit area compared to the management area. And conversely, if your effectiveness is not too good, or you've got a very small core area relative to the other pests you're trying to control, then you may have a small benefit area in relation to your management area. And then also you need to take into account what you're actually trying to protect. So you've got your birds there, and so there's a whole lot of differences that different species have in any core area, and you're also constrained by costs. So you have to try to minimize the core area as much as possible to minimize those costs. So if we've got a core area here, for example, how big should that be across? How many kilometers, for example, are we talking about? And say you could overlay a small bird territory, for example, and say, okay, so how much are we actually protecting by doing this approach? And as we scale up a core area, what are we actually protecting? So, for example, Tutuai, you could try to work out how many pairs you're protecting at that site. But then you might overlay a bird species that has a larger territory, and so you're protecting far less. And so you need to think about how big your core area needs to scale on that. And then I haven't overlapped, I haven't drawn other things because it just becomes a brown amorphous mess. But you could talk about overlapping medium home ranges of some species, and then large home ranges as well, that may go well outside your core area. Then there may be clustered communal breeding sites, and there may be other birds such as Pheo that live quite differently, and you may want to protect them and the rivers that they inhabit. So your core area may be quite different than a circle, for example. But you also need to think about sufficient genetic diversity. Are you capturing enough within these core areas? And if you're only talking about one big core area, then in the Kokako anyway, we know that we need to try to protect about 250 pairs to have a long-term genetic viability. But could that change if we have smaller areas and quite a few of them? So the next thing to really think about is if we're going to have quite a few core areas, how far apart should they be? And this is where I think a lot of research is required, is to really optimize that. It's going to depend on a whole lot of factors, including dispersal probabilities and the distances of different birds, their behavior, how they use the area, what kind of gene flow results from that, and also the cost, of course, in dollars. And so if you've got core areas that are a long way apart, you basically have they're basically in isolation and from each other. They're not interacting with each other really. But as you and so you get a kind of a density kind of thing like that, I suppose, if you can imagine that. But as you move them closer and closer together, you're starting to they're starting to influence each other a little bit with the spillover out of each core area, and then so they're getting closer and closer like that. And then as they get sufficiently close, the spillover areas start to touch, and so they will increase the baseline. And that's what I've tried to show there. That white arrow there. So is that increasing the baseline between core areas? So you're actually getting more birds in the bush in areas that you're not actually doing the management in.
Couple of minutes, Rhys.
Okay, just about there. And so you may say, and so that's the kind of idea there. But then say if you have a whole lot of these things all over the place, what does that look like? Well, your density kind of function may look a bit like that, and that could be kind of nodes and internodes, you could kind of think. So I think that to really know if this kind of thing could work, we need better modelling of this kind of approach, optimum layout, state what we really want to achieve. Is it one species in particular that we want to benefit? And can we even target super productive areas? For example, floodplain matai totara forests, and so you may get more birds per hectare in dollar spent. And even could you even think about core areas, making them fenced and pest free, and try to reintroduce highly threatened species back into mainland landscapes, but it wouldn't work for species that have to walk like kiwi, little spotted kiwi, if they're behind fences, obviously. And the density of core areas may change by habitat type, for example. And then I asked at the start, what would the extra investment be worth it? There's probably both financial and kind of moral answers, I guess you could say, about that. There are vast areas of our country, forested country, with very low bird density, and even if treated with 1080, can we really do better? And it may even help in the warm forest before the rat bounce, something like this. So again, just a blend of extensive and intensive control. So that's it. Any questions?
Okay, well, thanks very much, Rhys. I think you've already done pretty much what Birds in the Bush program set out to do. So you've done. It looks like the broad scale model that we hear mention of has kind of been done by you. So you might be in for a job with Landcare. Thanks very much for all that thought. Obviously, a lot of years of experience around various places going into that. So yeah, great. A couple of questions. So we've got John Innes asking, I really like your idea, especially its emphasis on multi-species pest control for ecosystem recovery, like a very large mainland island. So in a way, that Tamatuna thing the concept was quite fantastic in a way, a mix of extensive and intensive, like you said. We need sites like this scattered across NZ. Sorry, that was me, not John's words. Now we're back to John. We need sites like this scattered across NZ. Where, if anywhere, are there sites like this already? I can think of one or two, but can you, Rhys?
That have core areas as well as
Yeah, I
self-reinforcing
guess
core
so.
areas.
Yep. Yeah.
Well, I suppose, these big core areas like Zealandia and things like that, pest-free areas. But I'm not quite sure if I can't really think of other areas where do the extensive background area and then you have intensive area, much smaller areas of intensive control. But
Yeah.
where have
Okay.
you, are you aware
I
of
can think
some?
of one in the Oparara Basin in Kahurangi National Park, where there's background aerial operations, stoke traps over large areas, particularly focused on VO, and some nodes of ground-based rat control. But yeah, I can't think of very many
Nice.
more numerous
Sounds
places
ideal.
with traps. And yes,
Well, it doesn't have to be traps either. It's the other thing is that those, we kind of think about annual control as traps, but potentially in future you could use drone technology and you talked yourself about aerial pin down yesterday, perhaps other tools like that could be employed, and so you don't necessarily have to have infrastructure for those core areas, and so you could make it much cheaper if you can just fly those in between your aerial 1080 operations, for example.
Great. And if you could choose a site for trialing this, where would that be?
Well, one place is potentially the Rokumura. There's obviously a lot of things to talk about there, but there's a big 1080 operation about to kick off there. Other places like Kahurangi would be ideal, I think. Yeah, there would be a lot of places. The Wanganui area, things like that. Yeah, extensive areas, but they could even be used up, say, big South Island alpine valleys, or South Island valleys, where you could do core areas up a valley, and things like that in between your 1080 operations.
Cool. And Matt would like to know then, does the approach change once we increase resilience of the beneficiary populations? Can either the background or the cores become lighter effort once populations are healthier?
Well, potentially, yeah. And I was thinking that you could potentially even try to model things like you change your core area per year. So I talked about, showed those node kind of things over landscape. Well, potentially, if you don't set up infrastructure and you've got a aerial drone technology or something, you could change those core areas per year, so you're actually benefiting other sites as well. It'd be interesting to model that kind of thing.
Okay, well, that's great, Rhys. Thanks for your great talk and your great answers to those questions. We'll keep it rolling along. I think we're tracking pretty much bang on time. So yeah, thanks very much.